until this point, we have been writing fairly condensed or quote unquote simpler scripts or pieces of code, right? And we've been doing it all by ourselves. But what happens when we get, what happens when we make things more complex? As in, maybe you're not the only person working on the same script or maintaining the same body of automation. What if suddenly your automation gets really complex or long or involves a lot of files? What happens if this is something that needs to be maintained by a company over many years? At this point, we want to introduce a tool that is commonly used for a few different reasons. One of them is to make your code accessible to others. So instead of it living on your laptop at all times, meaning if your laptop breaks, if you suddenly get hit by a bus, if you quit this company and say, screw those people, then the company or your team or whoever still has access to the code. Or, for instance, if a new team member is on board and they can easily get access to the latest version of this code. So that's one reason you're going to use this tool we're introducing. The second important reason is because you need to keep track of changes over time. Now, again, it's harder to see when we start out with simpler scripts, but I want you to start out using this from the beginning so that when you're ready to do bigger and more complex things, you know what you're doing, you have the tools you need, and you're doing it professionally. So trust me when I say that when code gets more complex, or when there's more hands in the pot, or when it has to be maintained over time, that things are going to get complicated. It's sort of like if 50 different people over 10 years contribute to the same Google Doc or Word doc, right? It starts to get complicated as to who touched this, or should we have taken that out? Or does this even still make sense cohesively? And from the networking knowledge that I have, I do think that there are similarities to checks and balances and network engineering. For instance, when someone has to submit a change request to change the configuration on the network, there's an aspect of that to this tool that I'm going to be sharing. And basically the mentality is just, hey, we shouldn't just all be in there diddling around with the code, or in this case, the configuration, without having it approved or it being what we wanted to happen, or, blah, blah, blah. And you might be wondering to yourself, why do you keep calling it this tool? And that is because I want to make abundantly clear that the tool that we are technically talking about is software called Git, okay? You might have heard of things like GitHub or GitLab before, or Bitbucket. And these things we're going to touch in just a second, but what we're really talking about here is using Git, which is version control software. It allows you to see the latest version of code, to roll back to previous portions of code, kind of like, going back to a backup image of a device. It is this software that uses the command line that makes these things possible. Now, what does that have to do with things like GitHub and GitLab, which you might have heard of before? Well, GitHub and GitLab are the user interface. They're the things that you can interact with that aren't the terminal that allow you to use Git. And so GitHub and GitLab use this Git software on the back end, and it just makes it easier for a few different reasons that it's gonna become more apparent later. I don't want to bog you down with too much information from the jump. So when you talk about this tool with your friends, with your automation peeps, just other engineers, with developers, we're talking about version control. That is the skill that we're developing in this video. And the tools that we're using for this are the software Git, which actually manages the version of software, and we're going to explain how that works, and at a base level, at least at the I need to know it at this level. And then we're also going to talk about the code hosting platform or code repository, where that's going to live, which might be, again, GitHub, GitLab, or some other lesser known company. As always, let's get to it with real world examples. All right, so if we're going to get started with Git, let's start with this file that we've been working in the entire time. Technically, we have two files that we've worked in. One's just holding variables though, so I'm not going to worry about that one. Let's practice version control, or using Git and GitHub with this work we've already done. Quick note before we get started, we have not talked about code security or best practices yet, but just for the sake of security, I did remove the API key that I was using last time. So there's just an insert here now in the string. So if for any reason you go to this repository of mine and you wanted to use this, make sure you plug in your own API key. Okay, so to get started, first we have to make sure that we have a GitHub account and that we have Git installed. Now, this is gonna be cheating a little bit because I have both, right? I'm not starting from scratch here on my laptop. You would literally just go to github.com. You can use another code repository. It doesn't have to be GitHub, but this is a common one. You can sign up, sign in here. I am just going to go ahead and sign in. Okay, and I did my two-factor authentication. A lot of these repositories require that now, if you're not already familiar. And here's what my dashboard looks like. We've got a feed here. I don't don't ever look at that. And then I've got repositories over here and obviously a navigation menu. But this is where code gets hosted, like accessible via the internet, right? So you can put code into a repository. It's kind of like a project. So again, here's where I started the Learning Coding for Network Automation course. This Umbrella Uncommon Domains repository is a repository I share a lot in network engineering that I did last year. And you can see that the repository has a name, got all these files associated with it. Here's my README or instructions file. We'll cover all this more in depth in future videos, but I just want you to be aware of kind of what a project or repository looks like in general. And then there is this button right here that says code, and this is where either you or other people can basically install locally code that has been pushed to this GitHub repository on the internet. You can see that this particular repository is indicated to be public, so that means anybody can go to this URL, anybody can download the code. If it was private, then that wouldn't be the case. It would just be me seeing it, or anybody I've invited. So you have to make a GitHub account in order to get started. I can't walk you through that part, but when you have a new project, I always create the repository first. Technically, you don't have to do the repository first in GitHub. You can do it another way, but we're just gonna learn my way. So you see new issue, new repository, import repository. We're just going to do new repository, and let's call it, what do I want to call it? Learn to code with AI level 1 practice. I don't know if that's the best name. I really don't even know if you guys are going to end up using this. I just want you to have access to this code that I was writing the entire time. You can write a description. I'm not going to, well, actually associated with my YouTube course. If you've been following along, this was the code I was writing the entire time. And I guess I'll put at Erica the dev. Okay, choose visibility. I'm gonna make it public, but again, you can make it private. Add a README. I always automatically turn that on and I automatically create one, but you don't have to starting out. But again, every project does have an instructions file because then other engineers know, other engineers don't know how to use your stuff unless there's instructions. Git ignore is a file that I'll teach you about in the next level of the course. And then licensing, if I'm just doing stuff for myself, playing around, whatever, I don't even bother adding a license. But you can see that there's a lot of common use licenses, there's commercial licenses here, and they kind of tell you how other people can use your code. And if you're interested in that, I would recommend going to this link about licenses, because like I've not had to care that much, to be honest. I think in general, if I just create stuff that I'm happy for other people to use, I just use this Apache license 2.0. Like, it's just like a general use license, but again, you can look at the link at the details. So I'm gonna leave it unlicensed for now, and let's go ahead and create repository. And here's what it creates. It looks just like that other page, except it's mostly empty, right? We've only got one file, and then we've got this instructions file that only has that description I wrote. Now what, right? We've got a GitHub account. We've got a repository where we want to put this code that we've just written. Now, how do we get it there? So technically, you can use the GUI, right? You can just upload the files manually. However, you are missing the entire point, not the entire point, but you're missing a lot of the benefits of using version control software if you just upload the documents each time. And I'll explain that in a second. So just be aware that you can just manually upload your documents. And you're new to this, so play around with it. Like, it's chill if you want to start that way, even if it's not best practice. Then again, here is the links where you can clone. It's called cloning the repository. If I want to take what exists out there and bring it down on my local machine, I can do that. And I typically copy down repositories using HTTPS. Here's the URL for it. I mean, I don't really know why you would use SSH. I'm gonna be honest, I don't know. So you can look that up yourself. But I'm gonna copy that URL just so I have it already. But we have the GUI portion, right? We have the internet facing repository or existing on the internet repository where other people can access our code, even if it's just a few other people on our own team. But we do not have Git software installed, right? I mean, I have Git software installed. If you search for Git here, right? I mean, here's the folder where I have mine installed. And we can check this in the IDE too if we have it installed. So I can be in my terminal here, right? And git -- version, and it says I have Git version 2.49.0. So that's how you know I've already got it installed. But if you do not have it installed, you would go to download Git. I would just Google it. And then here you can see there's an install for different operating systems. So I'll just go to Git downloads here. and we've got Mac OS. I did use Brew in order to, or Homebrew in order to install mine on my Mac, but obviously there's different ways to install here. Again, sorry I cannot walk you through that. I actually really tried to have a fresh, I just bought this laptop recently, and I tried to avoid installing these things before I could record this part of the course so that I could truly show you from scratch. But I ended up working with getting a contract to work on a web app for somebody. So I kind of had to install these things. They're pretty necessary. But yeah, again, just keep in mind, you can install Git, all the operating systems. So you got to download it and install it. And then again, you can check that the install worked in your terminal using the git -- version command. And then here's what's going to happen. If I hit Git here, right, I can see all of the commands available to me. Now, here is the essence of what you need to understand with Git. It's version control software. And so every time you push your code to GitHub or to whatever internet repository that you want to, it is associated with a commit ID. And basically what version control software is doing is it's tracking each change, it's tracking each pushed code version, and then it's also tracking changes between that code and more code that comes your way. So what I mean by this is, let's say with this particular file, I push this code to GitHub, and let's say someone else pushes a second file to GitHub. So it is going to compare its current state, which has this file in it, to the new state, which on somebody else's machine would be this file plus a new file. And it's going to say, oh, hey, there's no conflicts here, right? They didn't work on the same code. There's nothing to dispute here. So as far as I'm concerned, this can be approved, right? And again, it depends on how you set up your team in GitHub. You can have like approval processes and stuff, but we're just starting out. It's just going to be like, cool. Yeah, if you want to, you can push this to GitHub, no problem. However, if somebody is working on the same file as me, like let's say that me and another engineer have installed this repository with this file that I've not yet pushed on our local machines, and we're both working in it for some reason. Like maybe we both are working on solving different bugs in the code or adding different features or whatever. So that means that when we both go to push, we're both going to have different versions of the project and specifically of this same file. That is where Git really comes into play because it helps you to resolve those issues. And Git saves the entire history. You can view it in GitHub, like in the GUI, right? But you can see the entire history. You can roll back to previous commits or versions of the code. And again, it's a lifesaver the more complex the project gets and the more people who become involved. Your code is really not that useful if other people can't access it, if they don't know how to use it, blah, blah, blah. If you want to know more about Git and you want to get really in depth and know all the theory, there are entire courses on Git. I can tell you that software engineers themselves, a lot of us are not Git experts, right? You're really going to use most of the time the same few commands, and that's what we're going to cover in this video. The other commands, you basically are going to like Google them or use AI to figure out when you need to use them and what those commands are. Obviously, again, it depends on what environment a developer works in and the kinds of challenges they've run into. But in my experience, most people are not Git experts. Here's these initial commands, right? You need to know how to clone a repository. So you need to know how to either clone a repository from GitHub locally or to create a Git repository from code that you already have on your machine. And again, this is going to sound a little bit abstract, but I promise you go back and forth pushing and pulling projects from GitHub a few times and it's going to start to click. It'll just be muscle memory, right? So we want to know how to both clone repositories from the internet and how to initialize them locally to be pushed out. We also want to know how to push the files to GitHub. And that is not actually just a single command. It's a series of 3 commands. We're going to go over that as well. And finally, the only other thing that you really need to understand is the concept of pooling things from GitHub. So let's go over each one of those now. And, if you see me make mistakes, it happens. So I've just created an empty GitHub repository. I actually don't remember if I can just clone it here and then add these files to it, or if I should be initializing the file that I have right here. So we're going to find out together. So git clone is the command with the URL that you would use if you want to pull one from the internet. So boom, now I have pooled that repository. It says receiving objects 100% 3 out of 3 done. So we're successful doing that. And if I open my file navigator over here, and now if I ls, now I can see the learn to code with AI level 1 practice, right? So I created it right here. I should have organized it better. I didn't, right? So you want to be in the directory where you want the repository cloned, like if it's in your documents or if it's somewhere else. But I did not do that. So let's go into the repository. All right, so now I'm in here. If I ls again, I see the README file, and that's what we saw created, right? When we created the repository, there was that README or instructions file, which is like a sentence in it. There's pretty much nothing in it. But that's all we've got in there. If we want to see, so we've officially cloned the repository. Now we want to push this file to the repository. And again, it's not just one command, it's actually a series of 3 commands. And the way this works is that with Git, you have to stage a file, you have to add a commit message to the file, and then you have to actually push it. So staging, think of that as like you're getting the file prepared. I'm gonna be honest, I don't really understand why there's a separate staging and commit message process, right? It seems a little excessive. Maybe if I thought about it more, I would remember why, but let's just go with it. Staging the file basically says, hey, we intend to push this file later. Like we're readying you up. Think about, I don't know what the network engineering equivalent of that would be, but kind of think of it as like if you were going into if you were in a play or musical, you're in the rehearsal room, right? Like they intend to put you on the stage that night and you're in the rehearsal room. More things have to happen, like makeup and costume in order for you to actually go out there. So if we want to see if anything is even in staging currently, we can use the git status command, and it says your branch is up to date with origin main, and we haven't even discussed branches yet. The short version is that, the shortest version of me explaining that, and it doesn't matter that you understand this right now at this point in the course, but the shortest version is that when you create a repository, there's always a singular branch called the main branch. And right now we're just working on that because it's just ourselves, we're just learning. But technically, as things get more complex, as more people get involved, as we go into best practices, we create additional branches so that individual engineers have their own branch to work on. And we have like development and testing branches that are separate from the main production branch. And we have processes for how we merge those changes into the main branch, right? We merge smaller branches into big branch once we determine, hey, all the code looks great. So that's all you need to know for that right now. So git status, this says everything's up to date. So that means that nothing is like sitting and staging. So let's go ahead and do git add, and we can do -- all if we want everything we've worked on up to this point to be in there. But I'm going to do git add, and then I have so poorly named this file. I'm going to do git add and then a dot for this file. So where did I save this file? All right, you have to be careful about where you save files, right? Because it needs to know where the file is. You have to have the ability to put it in the repository. I'm going to be really lazy and not use best practice, and I'm just going to save this with a better name. Like a slightly better name. Initial automation practice is what I'll call the file. And I'm going to go ahead and save it directly here in this learn to code repository folder that's been created. So now if I ls, I can see that the file is already there in this directory. I'm going to do git status, and now we can see that I have untracked files, which basically means, hey, we see that there is a file in this repository that is either brand new or has had changes made to it, but it is not being staged. It is not being prepared to be pushed. It is just like untracked in here right now. So we want it to be staged or to start to be tracked. So we're going to do git add, and again, we can do -- all, or I can do the name of the file. I'll just do the name of the file. So let's do a git status again. Now we can see your changes to be committed. New file, initial automation practice. So again, it has not been pushed to the repository. It's just ready to have a message added before it's pushed. And the reason we add a message is because we're not just all willy-nilly making changes in a code base or on a script, whatever, without any information whatsoever, right? Like same thing when you make changes as a network engineer, like usually you're documenting things or you're giving a reason for a change request or config change, whatever. Like you don't just do crap without anybody knowing what you're doing, or at least you're not supposed to. It makes everyone's life hell. So what we're going to do is git commit. -m is how you add a commit message, and this is where we're going to describe what we did here so that other people actually know what the crap this is or what changed. Now in this case, obviously this is just for practice. We're the only ones working on it, and there's honestly a lot of random things in here. It's just a brand new file, so it's hard to get real specific with this commit message, but we could say created file for initial network automation practice based on concepts discussed in Erica the Dev's YouTube course. Functionality includes standard IP address lookup using IP stack, creating structures for learning purposes, giving examples of variables in network engineering, adding days uptime between switches, showing IPS events when a firewall is active. This is a really long commit message, to be honest. But again, you'll learn best practices later. Traffic to a different ISP when link is down, when primary link is down. Okay, you're probably never gonna have a commit message be that long, but I'm trying to do my due diligence here. So it says, okay, one file changed, 85 insertions or plus signs. So it's saying that 85 lines of code were added, and that lines up with what we've done here, right? You can see we have 85 lines of code. This is a brand new file being added, so that all checks out. So now if we do a git status again, now it says, we're on the main branch, right? We're on the main branch locally, and our main branch locally is ahead of the main branch in GitHub. So we downloaded this repository from GitHub. We made some changes, but those changes are ahead of what's currently in the internet repository. We need to push those changes so that our local code looks the same as our publicly available code. So, and it says use git push to publish your local commits, and we will do that. So we'll do git push. The extension GitHub wants to sign in using GitHub. I'll allow it. So it's making me sign in. Okay, perfect. And so you can see counting objects, 100% 4 to 4 done, writing objects, 100%, blah, 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 to this URL, which is where our repository is. Looks all good. If we do git status, it says your branch is now up to date with origin main. Origin main is GitHub, the main branch of GitHub. Now let's go to our GitHub branch. I'm going to refresh the page, and now we see that file. It says it was added 1 minute ago. And here's that big commit message that we created. We can click on that and see exactly what was changed, right? And again, this is an exposure introductory course, so I'm not going to go all through this, but we can see the file and exactly what was changed. 85 lines added, nothing subtracted. And yeah, we can go into the file. Here's our file. Looks exactly like what we have locally. Okay, so you've just learned how to push your code to GitHub. The only other thing you need to be aware of is, let's pretend that again, you're not the only one working in the code base, and I'm gonna create a file here for giggles. I'm just gonna call it testing. Let's name it testing.py here, and just trying to show something. I'm just gonna add a comment. I'm gonna commit the changes. So I just created this file within the GUI. So now this repository remotely on the internet has something that we don't have locally. So now when I do git status, it's always a good idea to check on the status before coding. So you don't have to deal with conflicts and other crap. Okay, since your branch is up to date, that is not accurate. So I guess we need to do a git fetch, I think it is. And when we do git fetch, it says your branch is behind origin main by 1 commit. So git fetch went ahead and fetched what is happening remotely. Now we know that we're actually behind, and it tells us use git pull to update your local branch. And that's what we're gonna do. Git pull, updating, blah, blah, blah. Now we have it. If we do git status, we're up to date again. And let's see, let's look at our file structure here. I don't know why is it showing this and not the files? Let's open the folder. This is ridiculous. Trust the authors. Yes, I trust myself. Okay. We want the Explorer to have the files so that we can go between them. I can show you that again later. We'll practice that. But you can see that now that we fetched it, we can see that testing file that we just created remotely. Pretty cool, right? And then again, just to kind of reiterate over the concept of commits, right? It says last commit date. We can see the last commit date. And here's an example of the commit number, right? So when I created this testing.py file, it's associated with this commit message, or with this commit ID. And every time I make any changes to this repository, a new commit ID is created. So again, Git is, complicatedly on the back end, keeping track of everything by these commit IDs and comparing files and making sure there's no conflicts or problems. And yeah, I feel like that's all you need to know. I think it's a matter of practice now. I'm gonna work on making some practice content for you guys. Congratulations, you have made it through level 1 of this course, learning to code using AI for network engineers. Yay! You deserve a pat on the back. This is not an easy step to take. If you've watched all my videos and if you've been trying to practice hands-on, that takes commitment, that takes overcoming frustration and confusion, and I salute you. I'm so proud of you. If you didn't watch every video or you have gaps in your knowledge, that's fine. It's all part of the journey. We're all imperfect, but this is really, really exciting that you've gotten to this point. And the next level of this course, level 1 or 2, I can't remember what I'm calling it, is all about now introducing an AI coding assistant. So just as a quick reminder, it's all about introducing an AI coding assistant, specifically GitHub Copilot. Now, just a reminder for why we're doing this in this particular particular course and why this course stands out from others. And that is because I have been told countless times by network engineers who are trying to learn to code or to improve their coding skills, and that they just do not have the time. They don't have the time, or the education out there sucks, or is not domain specific, etc. And so I created this course using AI as a learning resource and not just a tool to cheat and to generate code. So in the next level of this course, we're going to be exploring using AI coding assistant as a learning resource by prompting and asking questions, and I'm going to guide you on how to do that effectively and through the topics that I know that you need to know. And this as a little preview, the final level, or at least at this point in time, the final level of this course is walking you through where you can use AI coding assistants to generate code. Because once we have an understanding of what we're doing, we can use the AI coding assistants to generate the boring crap that just is the same every time, among other things. So thank you so much again for sticking with this course, for investing in yourself, and for supporting my channel. If you haven't already, please subscribe. I'd love to keep doing this for y'all. As baby dev comes to be born soon, I want to do this full time, and I would like to make money off of it. So anyway, I'll see you in the next level of the course. Bye!